Okay. We are doing 8-3 today. Okay. I just wanted to say in the video that I graded the special right triangle work. I had about half of the groups do really, really well with it. Most people were able to finish almost all of the problems in class and did a really good job with them. However, there were some groups that really looked like they were struggling. So I wanted to let you know that when I pass them back, the assignments, you are allowed to finish the problems that you didn't get to and turn those in if you'd like to. So you can start on them now if you needed to or if you wanted to. I will collect any of 8-2 that you did not finish in class. All right, let's review what we've done so far before we start the next section. Okay. We've done Pythagorean theorem. Pythagorean theorem is used when you have a triangle and only one side is missing. Then we did special right triangles. Special right triangles are used when two sides are missing, but this only works when the angles are special angles. What happens if this was a 23 or 41? You couldn't use the special right triangle formulas. That's what we're going to do today. Okay? We're going to do 8-3. Now this section is technically just the tangent formula. All of the problems that you're going to do in class are just going to be based off the tangent formula. So that's the only one I'm going to give you. So tangent of theta equals opposite over adjacent. So what does opposite and adjacent mean? Now, first of all, what is theta? That symbol is a Greek letter, and we pronounce it theta, and it's always used for the angle. Okay. O stands for opposite, and A stands for adjacent. If my angle is here, now my angle could be either one of these. It just depends on which one you're using or which one you're given. In this case, if this is my angle, this is still considered the hypotenuse. These are both legs, but we're going to call this one the adjacent leg, and the one across from it is the opposite leg. Kind of makes sense. Opposite means opposite, so we're going across the triangle on the opposite side of the angle. Okay? All right. We're going to continue in the notes, and I'm going to give you 3 examples of tangents. Okay, so here's a problem. We can't use Pythagorean theorem because we're missing 2 of the sides. We can't use special right triangles because the angle is 31. So in this case, we're going to use the tangent ratio. The formula is tangent of theta equals opposite over adjacent. In this case, what is my angle? What is my theta? My theta is 31. Which one is my opposite? Out of these two, which one is opposite of the angle? Opposite of the angle would be x, and adjacent would be 51. In this case, there's nothing on the hypotenuse. Okay, so plug into the formula. The tangent of 31 equals x over 51. Now this example is for when the x is on top. How do you solve it when x is on top? Okay, this is x divided by 51. To get rid of the division, you would just multiply by 51. If I do something on one side, I have to do it on the other. Okay, So x equals 51 times tangent of 31. Then you're going to get your calculator. I actually just realized that I'm not sure how to turn these calculators into degree. I will have to show you part of this in class. You need to practice with the calculators in class anyway. But you're basically just going to type in 51 times. To get your trig values, there's a button right here that says trig. And you see that pops up, and you'll see sine, cosine, and tangent. We're going to go over to tangent. Okay, and our tangent is 31. And I don't know if this is going to give me the right answer because my angles have to be in degrees, and it did not. But when I figure out how to do the calculator in degrees, this should have given me 3.64. Okay? So I will figure that out before tomorrow, and I will teach you that in class. Okay, so when you plug into the formula, when your x is on top, you just multiply. Okay? Alright, let me give you another example. Okay, what happens when you plug into the formula and your x ends up on bottom? For instance, this example. Okay, again, we're going to be using tangent. Okay. My theta. Notice I'm identifying all of these before I plug into the formula. If you start struggling tomorrow, then do it the way I'm doing it. I know my theta is 42. The 6 is opposite. And the x is adjacent. So when I plug into my formula, I get tangent of 42. I don't know why I just wrote 24. Tangent of 42 equals, and in this case, I get 6 over x. Now, you cannot solve a problem that has a variable in the denominator. You never will be able to. Even when you get to algebra 2, you cannot solve an algebra problem that has x in the denominator. So how would I get rid of this? The same way I got rid of the, what was the number in the last problem? The 51 in the last problem. How did I get rid of the 51? I multiplied. Same thing. How do I get rid of the x? I'm going to multiply. But when I do it on one side, I have to do it on the other. That cancels, so I'm left with x times tangent of 42 equals 6. Now I can solve for x. Now to get x by itself, I can undo this multiplication by dividing tangent of 42. So x equals 6 divided by tangent of 42. I'll type that in the calculator in just a second. But if that didn't make sense to you, I did have some success last year by telling kids that when x is on bottom, to just switch these. Okay, the x comes over here, and the tangent of 42 moves to the bottom. You just have to realize that this is one huge thing. The whole thing moves over. Okay, I have had people in the past tell me that try to do this, and instead of doing it correctly, when I've told them to switch these two, they would tell me this. Okay, you're not switching the x and the 42. You're switching the x and the entire tangent of 42. So, whichever one makes sense to you, whether or not you actually want to do the logistical steps, or if you just want to remember to switch these, you can. I don't mind. Plugging this in the calculator, again, my calculator is not going to give us the correct answer because I don't have the settings right, but I can still show you how to plug it in. It's just 6 divided by trig tangent of 42, enter. Okay? You actually should get 6.664. Okay? Last example. When x is the angle okay. So again, write down your formula, identify all of the parts, in this case, if I look at my theta, the 7 is opposite, and plug into the formula. Okay, now, in this case, we're trying to solve for x, so we need to get rid of the tangent. One thing I need to make abundantly clear is that you have never heard me say tangent times x. This is not multiplication. It's tangent of x. Tangent is its own separate operation, just like multiplication and division, addition and subtraction, squaring, square rooting. We have tangents, cosines, and sines, which you'll learn tomorrow. It is a brand new operation that you're learning to do. This is not tangent times x. Tangent itself is the operation. And every operation has an opposite. The opposite of addition is subtraction. The opposite of multiplication is division. The opposite of squaring is square rooting. What is the opposite of tangent? Okay, it's actually called tangent inverse. So, to cancel these out, I have to do tangent inverse, and just like any other algebra, if you do it on one side, you better do it on the other. So, tangent inverse and I don't change this. It's still 7 over 21. I'm just taking the tangent inverse of it. Then on the calculator, if you notice, when I hit that trig button, what do you see right underneath the tangent? It says tangent inverse. So you would just hit that and then type in 7 divided by 21. Again, this isn't going to give me the right answer because I need to change the settings, but it should have given me 18.43. Okay. So, just to review. Okay. That's the first example. Alright. When x is on top, multiply. Okay. When x is on bottom, and x is on bottom, you just switch them. Okay. And when x is the angle, we do the inverse. Okay? Alright.